All right, let's start. We're going to look at planar graph and trees. Now, trees is important for you to understand what a tree is, because in Unit 4, you'll be looking at spanning trees. All right? So it's a concept that you will have to start to learn now, and it will take you to Unit 4. Planar graph is pretty important because we need to be able to identify planar graph and use the Euler's formula. All right? This is the only formula you're going to get, the Euler's formula, in terms of the graph theory and a network. All right? You won't get any other formula on the formula sheet except the Euler's formula. Right? Now, so yeah, what I really want all of you to understand today from the lesson is what a planar graph is. You must be able to determine if a graph is planar using the Euler's formula and actually drawing it out as well, and understand what a tree is. All right? Now, I want to start off with you looking at the foreground. Can you tell me what's the difference between the foreground? Or anyone can tell me what's the difference between the foreground? Are they the same? Are they different? Or what do you think? What do you think, Luis? What do you think? Are they the same or are they not the same? Why? Yep. So basically, what I'm showing you here is four graphs representing something. They are exactly the same. All right. So here, what I have is this graph here. I've taken BD outside that box, and I connect BD that way. This one I've taken D into the triangle. This one basically I put A, B, C, D in one straight line. Right. Difference between this, and this. This tree, there's no line crossing. Right? So the one without line crossing is called a planar graph. All these three are called a planar graph. And a planar graph is an undirected graph that can be drawn on a plane without any edges crossing. That is what you really need to know. All right. In the exam, you'll be given something like this. Okay, this is a straightforward example. You'll be given something more complicated to ask you to draw a planar graph or use Euler's formula to determine if it is a planar graph. All right? Or you'll be given a graph, and then you'll be asked to determine if you could actually remove one of the edges and it becomes a planar graph, and that sort of stuff. All right, there are quite a few variations in this in terms of exam question. So you need to really understand what a planar graph is. It's just an undirected graph which can be drawn on a plane without any edges crossing. All right, that's the definition you need to know. So I've proved to you that from one non-planar graph, I can draw three different ones. There are more variations. You can draw a lot more than just the three that I've shown you. Now, have a look at this. Which one of these graphs are planar? Example, can you identify which one? Now, the thing is, something like this, you must either redraw it, or if you can picture it, you don't have to redraw it. It's up to you. If you can picture it, you don't have to redraw it. If you can't, you actually have to redraw it as a planar graph. All right? I'll show you the example for A. If I want to redraw it, I can do it this way. Z, X, W, and Y. All right? I can do it that way. So X connected to Z, W connected to Y, and then X connected to Y. So I can redraw it. And hang on, I'm missing something. Z connected to W. All right? So I'm redrawing it, and this is the case. Or I can flip Y over. Y here. I've got X here, W here, and Z here. All right? And if I flip Y over, Y is connected to X, you can still draw the same thing. All right? So by redrawing it, I show that this graph is planar, although there's a cross edge. All right? Two cross edges there. Now, with part B, what can you do? How do you make it a planar graph?
It's a planar graph when none of the edges cross.
How do you make it a planar graph? How do you make it a planar graph?
Put n in the middle of the triangle.
Sorry?
Put n in the middle of the triangle.
Put n in the middle? Middle of what?
The larger triangle shape, like in the middle of n, j, k, and l.
N, J, K, and L. So, do you mean, are you moving this?
No.
Which one do you want to move? Are you
M.
moving the H or are you moving the
M.
M?
M.
And move in there?
Yeah.
Yep, all right. So if you move in there, it will become something like this. Yep. It is a planar. All right? That's fine. You can move the H. Or if you like, you can also move, you're moving the one of the vertex M. All right? Or you can actually move NL out. That's one other way. All right? Or if you like, you can move MK out. That's another way as well. All right? If you're asked to redraw this planar, you can do that. You can either take this out so there's no crossing, or take that one out, there's no crossing. Or like you say, move M up there. That's fine. Not an issue at all. So as long as you can identify it as a planar graph, you're all right. Sometimes they're asked to draw. This will probably be just a warm-up question, a one-mark question. All right? Now let's go on to the next bit. Well, I'm going to bring you to the Euler's formula. Before I start the Euler's formula, I want you to recall what is a vertex, what is an edge, and what are faces. All right? So vertex or vertices, just that set of points. All right? These are the points. Vertices, edges joined by a set of lines. Edges are the set of lines. And the faces, remember the faces. This is 1, this is 2, and all the others, they are connected together. All the other faces are connected together. They form one region, that's 3. All right? There is no separation between the face here because it's connected. No separation between here and here, it's connected. But there is a separation between this and that. Separation between this and this one. Separation between this and that. Therefore, there are 3 faces. From here, Euler came up with a formula. So it's linked the number of vertices, edges, and planar. All right? Together. Now note the first point. The number of vertices, edges, and faces of a planar graph remains the same no matter how it is drawn. All right? Let's go back to which one is that? Let's go back to this one. All right, you can see that for this. There's no change in the vertices. The main thing is let's look at the face. 1, 2, 3, 4. 4 faces for this one. 4 faces. 1, 2, 3, 4 faces, correct? I got 1, 2, 3, and 4 faces. If there's a cross edge, it's really difficult to determine the face because here, in there, depends on whether you take AC out or BD out. In there, there's only 2 faces, correct? It's not 4. You cannot consider that as 4 because of that. That is not 4 faces. You have to actually redraw it before you can actually determine the number of faces. All right? Now, this is also true for graphs that initially appears to be non-planar when they are redrawn to a planar. Let's I've done that. So they all have 4 vertices, 6 edges, and 4 faces. Now, let's have a look at the Euler's rule. This is the only formula that you'll get in the formula sheet for networks and graph theory. So for any connected planar graph, V is the number of vertices, E is the number of edges, and F is the number of faces. Then V plus F minus E equals to 2. You don't have to remember that it's in your formula sheet. You'll be required to use this formula to prove that a simple connected graph is planar, And you could be asked to use this to find either the number of vertices, or the number of edges, or the number of faces given the other two. All right? I'll give you a few minutes to write this down, and then we're going to look at how we could use this formula, v plus f minus e equals to 2. Yep. Because when it is crossing, what happens is it's not connected, and there is no, you've got to redraw it to actually see it. So I've redrawn everyone else. I'll come back to you when you see it, alright? It's just the way it's drawn. Alright. Now, let's have a look at the next question. Example. A connected graph has 10 edges, 7 vertices, and 5 faces. Show that the graph is planar. Now, you know that in this case, v is 7. Alright? V equals to 7. Why is it not doing that? V. Alright. I'm not sure what's wrong with it. It's not doing it. Let's try again. We know V equals to V equals to 7, E equals to 10, and F equals to 5. So, using the formula, V plus F minus E equals to 7 plus 5 minus 10 equals to 2. Alright? So, what you should say is, this satisfy Euler's formula as 2 equals to 2. Therefore, the graph is planar. Alright? And what I've done is drawn it for you. You may be asked to draw this graph. Alright? When if you're asked to draw this graph, what you may need to think about is start to draw it with the vertices. So I've done something wrong there. I've got 8 vertices instead of 10. So that's terrible. That's not right. So there should be, I've done something wrong there. I've got to get rid of one of the dots later. So ignoring that, ignoring one of the dots, so you have to draw 10 vertices. Start off with the draw dots first. Vertices first. If you've done it incorrectly, like me, you won't get the marks if you're asked to draw. So 10 edges. I've got 1, 2, 3, 4, 5, 6, 7. I need 3 more. 1, 2, and 3. Alright, there's 7 vertices. Let's check the number of faces. 1, 2, 3, 4, 5 faces. So that's correct. Now, if that's not the way that you want to draw it, you can draw something else, somewhere else. Like, I will still connect that. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's another way of doing it. So I still have 1, 2, 3, 4, and 5 faces. Alright? So there are multiple ways of drawing something like this. So you're either asked to prove using Euler's formula, or sometimes you may be asked to draw. If you draw it, what you really need to do is show that you've got 7 vertices, and 10 edges, and 5 faces. Alright? Now, even if you don't want to draw it this way, you can do it that way, and then connect one line there. That's still the same. Alright? There's no difference in terms of what I've done, proving that graph. Alright, you know what I've done there? Let's try this one. A connected planar graph has 6 vertices and 5 faces. Determine the number of edges and the graph must have. And then draw the planar graph. Yep.
Sorry, if a graph fits Euler's formula, does that automatically mean it's a planar graph?
Yep.
Okay. So graphs can't just coincidentally fit the formula?
It can't accidentally fit that formula, Euler's formula. Euler's formula always proves that the graph is planar. So can you try this please? 6 vertices and 5 faces. So you need to use that to determine E. This is probably the only topic that you don't need a lot of calculation.
Like, it's legit the exact same thing, just on this box. Probably, yeah. Oh, this is so fun. Oh, it's so fun to draw shit. I know. It's so easy to
Alright. Now, with question like this, identify the V and the F. And then write down V plus F equals to 2. Substitute V and F and then calculate E. And then always state that the planar graph has 9 edges. Answer the questions. Alright, always answer the question. Now, draw the planar graph. This is one example. I've got, this time I've got it correct. 6 vertices. And then I know I have to draw 9 edges. So what I do is typically connect it into a circle, 1, 2, 3, 4, 5, 6. I need 3 more. That's 3 more. Or you can do whatever way you like. If you don't want to do it that way, this is 3 more. 1, 2, and 3. 3 more. You've got 1, 2, 3, 4, 5 faces. Or like what I did just now.
just that.
You've got 1, 2, 3, 4, 5 faces. Alright? So there's plenty of way of doing it, and we'll accept answer as long as it's drawn as a planar graph. Alright, please do not cross edges. Yep.
So are planar graphs simple graphs?
It can be.
Because I thought a simple graph can have multiple edges.
Yeah, this can have multiple edges.
So it's not. Wait,
Yeah.
does it have multiple edges?
I think so, yeah.
No.
I didn't ask him, I think he might have a disconnect.
Yeah.
Can planar graphs not be connected on one of the edges, like the vertices? Like,
Yes, you can. Because, like, for example, planar graph, the one that I've shown you in this situation is a planar graph. Alright, that's a planar graph. Alright?
Wait, so
Yep.
a loop counts as 2 edges, right?
Sorry?
A loop counts as 2 edges.
Yes.
Alright.
No, it's 2 degrees going in. Alright?
But it's 1 edge.
1 edge is something like this. That's 1 edge.
I know, but what is a loop? How many edges?
Loop is, I'll get back to you in a few minutes. Alright? Let's do the next bit first. Alright, let's try this question, please. Can you actually redraw the graph? You need to be able to show the following graph is planar by using, by redrawing it, or by, oh no, actually by redrawing it also by Euler's formula.
it's too easy for me.
All you need to do is make it a hexagon again.
No. You literally
Try this,
just
please.
move the line to the other side.
So, is that a point? I don't know.
It was a wiggly point. It's just, actually, this is the point.
Oh, very.
It's very simple. I already figured out the calculation as soon as I saw it. I knew.
You know.
negative 2, is that still valid? Wait, so
Yep.
if it's a negative 2, is that still 2?
No, negative 2 is not 2.
No, what do you mean?
You have done something wrong.
Bro, you flipped something. Yeah.
Alright, yep. This one, you got to draw the
You
graph
can
first.
make a house here.
Draw the graph first, draw the planar graph first, so there's no edges intersect
And
or
nice.
no edges cross. Once you've done that, you can work out the number of faces. Here, if you look at this, you know that this, that's not a face. This is not a face, 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 because there are edges that's crossing each other or intersecting. Alright? So, what happened is, you need to redraw. So I'm redrawing it by bringing out to the other side. If I bring out to the other side, I can redraw the whole thing. Basically, this triangle is actually turned around and just move across to this side. So I've got that. And from there, I know that there are 5 vertices, edges, 1, 2, 3, 4, 5, 6, 6 edges. Work out the face, 1, 2, and 3. 3 faces. So use your Euler's formula, and always it's important to prove. State 2 equals to 2 when Euler's formula is satisfied and the graph is a planar graph. Now, in the last 2 or 3 years, we have been taking a mark off when people don't say that 2 is equals to 2 and Euler's formula is satisfied. Alright? Always make that statement. It's quite important for you to do that, especially in the exam, to prove that 2 equals. You need to prove B plus E equals to 2, 2 therefore equals to 2, Euler's formula is satisfied. Alright?
So,
Yeah.
do you have to label like R, like the vertices?
Yes, you've got to, you must label. When you redraw, you must always label it. If not, you don't know what the vertices are. You must always label it. Alright, the last bit. Oh, actually this one, it's just to show you this is from your book. You don't have to really remember it, but just realize that sometimes things like a cube can be drawn as a planar graph. So the top bit is there, the bottom bit is there. Alright, a tetrahedron, that's
all of the dice of platonic solids except
the,
D10.
that point is here and the other 3 points is at the bottom. So you can actually draw some of the what you call platonic solid into a planar graph. That's in your book, you don't have to copy it down, just for your information. Finally, trees. Trees, any connected simple graph that contains no cycle is called a tree. Alright? So you can see that the top 3, they are trees. There's no cycle, there's no loop as well. Alright? The following 3 at the bottom are not trees. There is the first one, there's a cycle. The second one, that's not connected, therefore it's not a tree. Third one contains a cycle, therefore it's not a tree. Alright? And also if it contains loop, it's not a tree. Now, the next bit, all 3 with n vertices will have n minus 1 edges. You should write that down, you should make a note of that. It's not in your formula sheet, and I've seen it in the exam before. Alright, in the tree, every edge is a bridge. So make sure that you know a tree with n vertices will have n minus 1 edges. And in the tree, every edge is a bridge. So you can see that it's just pretty much like this one. You've got 1, 2, 3, 4, 5, 6, 7 vertices. You've got 1, 2, 3, 4, 5, 6, 6 edges. 1, 2, 3, 4, 5, 6. So you got 1, 2, 3, 4, 5, 6, 7. 7 minus 1. 7 minus 1 edges. Alright? Same with this one. 1, 2, 3, 4, 5, 6, 7, 8, 8. You should have 7 edges. 1, 2, 3, 4, 5, 6, 7, 7 edges. All right. All right. So I'm going to stop here. You should have some exercises to do from club. So what I've done today is basically explain to you what a planar graph is and understand what a tree is.